Welcome to the Explainer. Today, we are getting into one of the most essential tools in any 3D modeler's toolbox, the sweep. It's all about turning simple 2D curves into amazing 3D forms.
All right, let's kick things off with a question that every single designer runs into. You've got this great 2D shape, right? A profile. But what you really want is a three-dimensional object. So how do you get from A to B? Well, the answer is actually really elegant and kind of simple. You just give that shape a path to follow. The space it carves out as it moves along that path, that becomes your 3D object. And this whole powerful idea is what we call a sweep.
Okay, so let's get into the nuts and bolts of this, starting with the most fundamental version of the command. This is the classic, the original, the one-rail sweep.
So what is it? At its core, you've got just two key ingredients. First, you have your cross-section. That's the 2D shape. And second, you have a single curve, the rail, which is the path it's going to follow. That's it.
You know, the best way to think about it is with a super simple analogy. Imagine your cross-section is a train car, and the rail curve is the train track. The 3D object you're creating is just the tunnel that train carves out as it moves down the track. Simple, right? But incredibly powerful.
But what if you need a little more control? I mean, what happens when one track isn't enough to describe the shape you're imagining? Or maybe the form you want is actually defined by two separate edges? Well, that's exactly why we have the sweep to rails command. By adding that second rail, you're essentially creating two tracks. And this is key. It forces your shape to stretch, to scale, to morph as it travels between them, giving you way more precise control over the final surface. And this is a perfect illustration of that cause and effect relationship. Over on the left, you've got the raw ingredients, the two rails, a couple of cross-sections, and on the right, you see the beautiful, complex surface that they create. It's that direct.
So everything we've done up to this point has been about creating static objects, right? You run a command, you get a shape. But the real game changer is when we stop just building objects and start building systems. And for that, we're going to jump into Grasshopper.
To really get this, you have to understand the fundamental shift in thinking. In Rhino, you're doing what's called direct modeling. You click, you pull, you create a specific thing. But in Grasshopper, you're building a procedural system. You're designing a set of rules that generates the object for you. It's the difference between making one chair and building a machine that can make any chair you want.
Instead of typing commands, Grasshopper is all visual. You have these little components that you connect with wires. Data literally flows from left to right, from upstream inputs to downstream results. Each component takes in data, does something to it, and spits out a new result that flows into the next component. It's how you turn a set of rules into real geometry. So, how do we build our sweep in this new world? Let's start with the absolute workhorse, the sweep one. Seriously, this is one of the most important components to master. It's the go-to method for extruding a shape along any custom path you can dream of. The setup is super straightforward. You drop a sweep one component on your canvas. You create a parameter to pull in your rail curve from Rhino and another one for your section curve. Then you just wire them up and boom, Grasshopper builds the surface for you. It's that simple. Now, let's build on that logic. For the sweep 2 rails, it's the exact same logic, we're just adding one more curve to the mix. Step 1, you grab the sweep 2 rail component and put it on the canvas. Step 2, you set up parameters to reference your geometry from Rhino, this time your 2 rail curves and your section curve. And step 3, you connect the dots, wiring each curve into its correct input. And this is the part that matters. Each piece of your geometry, your 2 rails and your section, has its own dedicated slot on the component. R1 gets the first rail, R2 gets the second, and S gets the section. You are literally wiring your design intent directly into the logic of the tool. Okay, now here is where the real magic happens. What if, instead of just using static curves from Rhino, we start generating parts of our geometry with something like these number sliders? All of a sudden, you're not just modeling anymore. You can tweak a radius or change the number of components and watch your entire 3D model update instantly. You're actually exploring hundreds of design possibilities in real time. And this right here is the biggest shift when you move to parametric design. Because with this system you just built, you haven't really created just one single object. No, what you've actually built is a system, a repeatable, adaptable, flexible design machine that can generate an infinite number of variations, all based on the rules and the logic that you created. So we've taken a pretty simple idea, a shape following a path, and turned it into an incredibly powerful parametric tool. The final geometry is no longer the end goal, the system itself is the design. So that leaves just one question, really. Now that you know how to define the rules, what are you going to create?